cool. You should be able to see my camera and everything too. Awesome. Okay, cool. Hi, I'm Mariah. I am a dev here in Atlanta. I work for a company currently called Hudson and Mounts. I've been doing dev work for a little over 3 years. Full stack, but mostly muted. Give me 1 second, guys. Just having all kinds of difficulties. 1 sec. Can you see my camera now? Sorry, I'm so sorry, guys. Can you guys see my camera, or is it just?
Yeah, you're good. We've been seeing it this whole time.
Okay, cool. Yeah, so it's fine. All right, no worries. Cool. Thank you, guys. I'm so sorry. All right, so I'm going to do a presentation today on component libraries. I was going to do a full-on demo, but I think I've decided it's probably best to just go ahead and use an application I've already spinned up with a library and kind of like walk you guys through the decisions and making it, and do a little like storybook demo in the meantime. Hi, Martha. So I'm going to go ahead and get started on that. Let me share my presentation. Also, this is my first time doing public speaking pretty much ever, so bear with me. If I stop making sense, somebody let me know. And you should be able to see the tabs now. Cool, awesome. So I guess we'll just jump right into this and talk about what component libraries are. I think most people have probably dealt with a component library. If not, component libraries are just a collection of reusable, flexible user interface building blocks. We call them components. So let's see, sorry. Examples of these components, some simple examples are things like buttons, inputs, cards, checkboxes, and radio buttons, which kind of fall as a subset of buttons. These type of components usually have like 1 or 2 actionable elements to them. You can click on them and they do something, or they emit an event. Inputs and cards are more like, cards are more like containers. Inputs are more like for adding in text. And kind of like build off of that, you can make them more complex. So type aheads, usually you'll use an input and a type ahead, and you start typing in text, and it can pull up any type of, maybe you could do things like it contains a certain number of the letters. So if you have a list of things like dog, cat, and you type in D, it'll pull up dog. That'll be a type ahead. Modals are those little windows that pop up that have like kind of like a gray background on them. Nav bars will be the things that you see up at the top or on the left-hand side. We call them side navs that allow for navigation in between iframes. You can do it with, pretty much do it anything that you want. Very helpful for, navigation, of course. Date pickers, you can pick dates. Usually you'll see them like within a popover, a modal. They're very complicated. They don't sound it, but they totally are. And paginators at the bottom of tables when you click on new pages, rendering that increments in page and decrements in pages, that kind of thing. So these are all actual just components. Some are more complex, some are more simple, and some of them implement other components like the type ahead. So why do we care? This is actually super important, probably not in the beginning of your careers, and going forward, like as you start working on mid-level, senior level things, you start writing the same components over and over and over again. It gets a little old. So things that we're looking for when we do component libraries are easy implementations, reducing the time of development as a developer, not having to rewrite the same component over and over again with slight tweaks. But it doesn't just affect us, it also affects the users and it affects the brand, right? So for component libraries, we often will see that brands request that the components look a certain way. And that's important, we'll talk about that in a minute, but they'll say, well, I want my component to look like this. I want my buttons to look like this. I want my data to be laid out in a very specific way, and component libraries help for that kind of thing. And for the users, being able to just click on a button and already knowing what to expect from its functionality is very important. If they click on one button and it does a type of animation, and they click on another button, it does a different type of animation, this can be a little jarring in the user experience. So consistency is key. Visual clues, so things like if you're clicking on a button and there's a spinner that starts loading inside the button, it lets them know something's happening. If you implement a component in one application, and it's just a button, and you implement it in another application where you're using it to load another page, you may not give the user the same feel. They're actually expecting something to let them know that it's loading, and you kind of lose that functionality if you're just copy pasting components. And a really important one, which I'm going to bring up a lot throughout this presentation, is accessibility. Components need to be accessible. They should be accessible. They're usually not. But it's really important because there are users that have impairments, like visual impairments, and it's very difficult for them to see components sometimes, especially like older components. If it was made to look with like, I don't know, a hot pink button with, you know, like very light pink text. It looked really cool in the 90s. It does not look cool anymore, and no one can read it. And that can be amplified for certain users. So very important we cover all these bases. So how do we go about covering these bases? We look at the foundations of component libraries. But to preface this, you do not need to have a DLS to have a component library. The component library is just a collection of the components and a one convenient spot that you can implement throughout many applications, or one application if you so choose. But design language systems, which we'll go into what those are. If you want, you can read the little description here from Wikipedia, are fundamental in developing these accessible, consistent components that give the look and feel to the application. So to kind of touch on that a little bit, what is a design language system and what is it not? It's a style guide, it's a pattern library, and it's a living ecosystem that will change and evolve over time. It is not a component library. So if you build a component library, you have not built a DLS. It's not a color scheme. It's not specific to any framework or language. You will not build these specifications around Angular. You won't build them around React. You will not build them around JavaScript. They are very conceptual by design. They are very descriptive, and nothing more than that. So in general, I would like to look at it as a list of like undocumented pattern, or sorry, we want to look at it as a list of documented patterns and styles established from the dev teams, the UX team, the whole entire group of people that will be using it. It's not specific to any team. Product doesn't make it, devs don't make it, UX doesn't make it, they make it as a collective. So some examples of those, which I'm sure you've seen before, especially the first one, is Airbnb's DLS and IBM's DLS. Amex has one, Cabbage has one. Everybody's kind of jumping on board with this. It's great for your brand. It's great for the devs. Takes a whole lot of work off of us. So some things to note here in the top left, these are the documents for the DLS. So the documentation from Airbnb, they list the A11Y colors palettes, they list their typography, their font faces, their sizing. I don't know if they show it in here, but there's like a bold aspect to it. They'll show their spacing, so their spatial layouts. Right below it on the left-hand side is an example of their components. So they're showing you like headers, rows, messaging, how these like pages would look with these components. And on the other side, we have IBM, who's going to be showing you something like more like their grid pattern. So distance between things, what type of media they would be in. So like your phone, human, yeah. So they use human scale print. They have everyone has different names for different things. So these type of documentations are things you would see for a DLS. No, there's no actual like implementation of the components. It's not a sandbox. These are just documents for the building pieces of your component library. So key concepts in DLSs, kind of talked about them a little bit. Colors, typography, layout, and accessibility. Those are the four big ones. We're gonna talk more about them in a second. But other key concepts, all components need to be reusable. In component libraries, there's no point in building a component that you're going to use once. We'll go over that later too. There's no point in building a component that can only be used in a certain circumstance. So say you have an input, but you can only use the input on one type of page, that's also useless. So you want to make sure they can be reusable and flexible. And all components in design should be AA conforming by WCAG 2.1 or 2.0 standards. I won't go into that. We're going to post this later up online, so you can click on the link. It's a very extensive documentation, but is essentially just the guidelines developed with the W3C process as a collaborative movement to make web content more accessible. Fun fact about that, for instance, one of the big things about, I'm so excited to talk about this. One of the big things about this presentation to show like the differences of AA conformity and components is that in these title pages, like, let's see, let's go back a couple, like here. where we have the dark purple blue background and the white text, is actually more accessible or easier to read than the black/gray text on the white background. The contrast ratio is 9.94 to 1 instead of 9.89 to 1. It's very slight. And of course, like 9 to 1 is huge. The base for AA conforming is 4.5. So it's not significant, but it kind of like goes against your assumptions that, oh yeah, dark text on a white background is so much easier to read. It's not necessarily. So these are the kinds of things you'll learn when you look into those types of documentations. So last key concept in a DLS, it's more of an optional concept, but it's incredibly helpful for everybody from product to UX to us as devs, is sandboxes. It allows for like visualization, interaction of components once they've already been built, and to see like how UX's specs of how they want it to perform, the animations, how they come to life. Gives you a really good idea of the look and feel without having to actually like put it into the page first. A lot of devs like to use it so if they want to implement a checkbox, they already know kind of how to visualize their page if there's no mock to go off of. So let's see. So I said we're going to talk about this a little bit more. It's very important, more on colors, typography, layout, and accessibility. I did mention this before as well. Colors should be accessible for text. It is 4.5 to 1 for AA conforming and 7 to 1 for AAA conforming in their color contrast ratio. Super important. That being said, color palettes in general, if you pick the right ones, are incredibly helpful to maintain that contrast ratio. From my experience, usually the team will pick 8 to 12 neutral colors, so ranging from white to black. 4 actionable colors, so success, error, warning, and disabled. And then 2 to 4 accent colors and 2 primary colors. So you have like your brand color and then a primary color, and then have 2 to 4 accent colors. It's up to you guys. You can always like have more or less, but you have too many and it starts getting a little rough to comply with and design with. If you have too few, then you may not be able to express your application the way that you're looking to for the brand. So that's something that will be under debate when you're developing. Typefaces, the fonts and stuff, oftentimes are more for a larger company. They tend to be a little expensive. You can buy them from people, you can make your own, it's up to you. But it's very important that you maintain how your typography looks, your font weights, your font sizes, how big is your header, is it bold, is it not bold, that kind of thing. Spatial systems are another one that are really big. So they help to create a balance and a feel for your page. When you have a card that is, maybe padded 20, and then there's another card right next to it that's padded by 10 pixels. They're going to look completely different. It can be very jarring. It can be kind of rough as a user, to look at that kind of thing. So having consistency with your spatial systems is important. Most design language systems use 4-point or 8-point baseline grids. So every increment in size is by 4 to 8 points. I think 8 is the more common one, but don't quote me on that. Also, things that are involved in spatial systems are element first versus content first. So when you're implementing a component, are you more worried about its content? Are you more worried about the element itself? Are we worried about the height of the element? Or are we worried that the content is going to be 10 pixels padded everywhere? Inside and outside border placements, things like border box versus content box, where with border box, which is what the web generally uses, it like pushes the border and the padding against the content. And then a content box where the border and padding are defined like outside the width. Do you want to just like append the 2-pixel border on the outside, or do you want to include it when you're doing your dimensions? These are all questions that you're going to ask when you're working on your spatial systems. Another small one, but obviously still important, is like line heights. How far away is your lines from each other? Too close, they start to overlap. Too far, it looks kind of like you're writing a paper for college. So your choice, something to talk about. As far as actually debbing them out, your naming is very important. You want to make sure that it's a consistent type of naming and also it's readable. So for example, with colors, you'll often see like primary dash, link dash, brand dash, disabled dash. And then for sizes, you'll see like for font in particular, like body dash size, like small. We do t-shirt sizing usually. Other people choose different ways. But you want to definitely do body header. Maybe there's some other ones that you would want to do. Padding is kind of similar t-shirt sizes, padding small, margin medium, border medium. All these are stylistic and preferential, but having consistency in that naming is important. And you can always build utility classes to kind of help build off of that. So you can implement they're not, I guess they're not too important. I don't want to go too much into them, but you can, they're kind of like helper classes for CSS where you can like further expand on, rather than doing just like padding small, you can do like, I don't know, padding small, link, like it doesn't matter. You can append whatever you want to the end, but oftentimes you use them for like reusable styling. And all of this, super important. Sorry, 1 second. Sorry, 1 second, sorry. I didn't even see the comments. Cool. I'm so sorry, guys. I didn't realize I was talking fast. What type of component, simple or complex, should headers and footers fall under? So it depends. Headers and footers, I guess I wouldn't consider simple components. They're more like containers that you put at the top and bottom of the page. But if you want to make them actionable, you can make them into complex components, right? So footers usually just contain like blocks of text and navigational links. And you can have like a footer that's spec'd out a specific way. All the text maybe like is centered and goes in the middle. And it's, I don't know, fixed to the bottom of the page. I would consider that probably a complex component. But if you're just asking, like, if I wanted a container that I put, you know, text in and I want to be able to put it in a certain location on the page, you're probably just looking at a simple container component with some styling in it. It depends on how you and the in UX kind of mock it out, what behaviors it has, that kind of thing. Sorry. Cool. So going back to the thing, hopefully everyone can still see it. If not, let me know. The process of doing that, kind of, I guess that kind of segues into this as well, is what you would expect to happen is you create the design language system, right? You say, okay, we have all these different elements. We know exactly what we want it to look like. And then you mock up the components and then you choose your tools and you start doing. What actually more happens is that they are done in parallel. So I mentioned earlier the DLS is a live ecosystem. It will constantly change. It will constantly be different. Brands will be different. You may choose that you guys picked certain, you decided you wanted your bold font to be, you know, 800, and maybe that's just too bold. We go back to 600. These kinds of things change over time, and it's important that they do because you want your DLS and your component libraries to become better. And usually the first time around, not everything's perfect. So while you're kind of like working with this dynamic ecosystem, you're also creating these mocks for the components. Most components don't stay the same. Usually you'll say, okay, I want to make a type ahead and I'm going to pass it, you know, this value. And then when you're integrating that type ahead in an existing application, the input is no longer usable, especially if you get too specific with your inputs. So if you say, well, I need an input where it's an object and it has a key named ID, and then you integrate it with an application that exists and that object doesn't have a key with an ID in it, your type ahead's useless. You can't use it you can't put it into your current application that wants to use your DLS or your component library. So you have to change that component. You have to make it more flexible to fit your needs. That happens a lot. It's fine, it's normal. And the better and more flexible your component library and your DLS become, the more people want to use it, the easier it will be for devs to implement components. And I highly recommend constantly reviewing with your teams whether or not your DLS and your component library are working for you. Let me see, did I miss anything on this page? Yeah, tooling, I guess tooling also is really big on this. I wanted to use this example because back in 2017, when I had just started in software development, a little bit after, but you know, early on, they were still using a sandbox in Atlassian, which if anybody doesn't know, they do Jira. And they had a little sandbox I think it was in Confluence, but I could be wrong. It was a long time ago. And it was basically just where the designers would put in a little bit of CSS code they rendered, and the component was minimally interactable. You could like copy the code, and that was about it. And at the time, Storybook was very young, and we were not using it. We were talking about switching over. And looking back on that now and seeing the functionality of Storybook is incredible. Like, it's completely worth it to integrate it. So just one way in which the DLSs are constantly evolving. So we talked about the DLS. We talked about how we're going to have all these specifications and we're going to have all these design aspects that we have mapped out. What about the actual library? For us, I mean, this is an Angular meetup, so we would want to use Angular libraries, and Angular libraries make everything so easy for us. The line of code I have here for the CLI, the ng generate library, and my component library, will pretty much just do everything for you, and I will show you that in a minute. So the CLI, which everybody hopefully knows and loves at this point, generates the skeleton of the library and allows for packaging, right? So what it does right now is we're going to generate a new workspace without a create application. So if we do it without the create application equals false flag, we're going to get an application with it, but this is a library. So we don't want that. We set it to false. It's fine. I'll show you guys in a minute. And then inside that workspace, once it's created, we'll generate the library with that command. It's going to update the angular.json and assign the project as a library type, which helps define it. And then we can publish it or symlink it. So disclaimer, symlinking, which was great for Angular 4, has some trouble with the older versions, or sorry, the newer versions of Angular. So you're better off either like packaging it with like ng packager or publishing it with npm. Another way that we can do it is using Storybook for local development. And a disclaimer on something like that is that it's in an isolated environment, so you can't really tell how it's going to interact with other components around it as well. Whereas in like if you like publish it and you put it in the application, you can actually see how it'll interact. If something's off, if something acts weird or unexpectedly. It's up to you. Using both is recommended, honestly. Storybook makes for quick dev. Publishing makes for great integration. So it's up to you guys how you want to do that. But if you want to symlink for some older versions, using npm link and running with preserve links or adding that to the angular.json will help you do local dev and inject it into your application, and you don't even have to worry about like publishing anything. You just have to build it. Let's see next. So important notes about using Angular libraries. Important to pay attention to your dependencies. Not listing Angular dependencies as pure dependencies can break the parent application if the versions don't match. So make sure you pay attention to that. You won't want to use dependencies in general. Like, you want to use dep dependencies and pure dependencies, and not dependencies themselves. You'll get a little warning if you do. It'll say you need to explicitly whitelist your dependencies. It's for your own good. So if you're going to use symlinking, libraries must be built. If you do that preserve symlink, then it will go ahead and every time you build it, it'll reestablish it in your parent application, so you don't have to worry about going back and relinking it and unlinking it. If you choose to publish and install the library, it handles the symlinking for you. It handles the, all the things that symlinking would do, it handles it for you. One of the things that is important about publishing, which some people know, some people don't, so it's really important to bring it up, especially if you're working with a new application, is Ivy. So from Angular themselves, they, sorry guys, they state it's not recommended to publish Ivy libraries to NPM because Ivy generated code is not backwards compatible with Vue Engine. So apps using Vue Engine prior to Angular 9 won't consume them. So Vue Engine is different than Ivy because it's a different compiler and renderer. That's pretty much all I want to say on that. It's not related too much to us, other than the fact that if you try to like do anything with backwards compatibility, your application will break. You can get around it by going in and disabling Ivy. I'll show you how to do that in a minute. But otherwise, like if you're on an older version of Angular, or your library kind of already exists, you don't really have to worry about it. So I don't want to spend too much time on it. Also kind of an important configuration. You can use the TypeScript path mapping and map your peer dependencies for Angular in your TS config, so that you're always pointed to your local node modules. It's super helpful, I recommend it, so that we don't have to worry about mismatched versioning. So two things not related to either of those. Secondary entry points you'll find are useful when you get a little more intense with your component library. You can use specific components rather than importing all the components this way. It's great. You don't have to bring in all of their dependencies. It's really cool. Again, something you would do more once your library is a little more established. And versioning of the feature development. One of the things we found in the last DLS I worked on was that when your versioning's off and two people are trying to make a component on the same version, it does not go well. Everybody's builds get all messed up. So definitely consider how you're going to work with like Sumvar and versioning of your library. All right, so other component library tools. We're going to use Angular libraries. What else? So I felt like this was probably going to come up. I wanted to cover it a little bit. Angular elements and web components. So web components, for whoever doesn't know, are framework independent custom components. They follow the same specifications that we would for any other component, where we're basically just creating these components that can be used, that are reusable, that are completely custom built, difference being they're not framework dependent. So for what we're going to be working on, I'm going to be showing you it's Angular dependent. Angular offers a way to make them not Angular dependent. And we're going to do web components, which are more flexible with browser compatibility. There's some nuances to that. I'll get into it in a second. Let me see. I don't think I have anything else on this page that I really want to talk too much about. Stop me if you do want to hear a little bit more about them. A couple things that you have to worry about with web components, and the reason I'm not going to go over them today. They have a lot of little quirks, like you have to pass the injector into the web component so the dependency injection works. You have to put the web components in the entry components array so it can be bootstrapped, along with a create custom element, which is used to create the web component from an existing component if you need to. And then you have to like implement the ng-do bootstrap. Selectors pass into the custom elements.define has to be 2 or more words in kebab case, because if not, custom elements may not be able to tell the difference between native HTML themselves. So there's a few things that can be a pain when we start working with that, which is kind of on this page. And in relation to cross-browser compatibility, they're not really always cross-browser compatible, so you have to use things like polyfills. And when the polyfills become deprecated, like the HTML polyfill did, it breaks websites like it did YouTube. So there can be some issues with that. Usually it's good, usually it's fine, but always you have to keep in mind of that. They do require JavaScript, so if at any point you need to serve something statically, like just an HTML page, they won't render. You'll have to handle component degradation. And they don't have great ARIA support. So going back to that accessibility thing, there are some issues with like changing the roles, where if you have a custom component wrapped around a regular component and the component's role is set, and you change the custom component's role, it may not reflect, and the screen reader will instead read the parent's role. So they change things using attributes. And the attributes don't work that way with ARIA role, for example. So we'll see some issues. It's important to know them, but it's also important that, if you want to use web components, there's nothing wrong with that either. Just be aware. So other tools we want to look at that are not web component related are component behavior tools like Angular Material CDK versus your own custom built behavior handling. Documentation tools like Herman, Bit, Compodoc. Sandbox tools like Storybook, or you can make your own, and mockup tools like Sketch, InVision, Zeppelin. You'll probably be more worried about the sandbox tools, documentation, and component behavior tools. So one of the component behavior tools that we have available to us is a CDK. The CDK, by definition of this website, is just a set of behavior primitives for building the UI components. This means things like portals, which are essentially just component template ref or DOM elements rendered in a portal outlet. Even more simply, they are just content rendered in an area of a page. But it is crucial if you're going to develop things like overlays. So modals, popovers, that kind of thing. We're also looking at things like component harnesses for testing, which I'll talk more about later. Observers, so content that's projected. You can use observers to like get that content, which is great because for the most part, when you're making component libraries, pretty much everything's going to be in an ng content. And then they have a lot of tools for the A11 in the A11Y module, like focus trap. So when somebody's in an overlay and you have like keyboard accessibility, so you need to tab everywhere. You don't tab out of the modal on accident and then have to go all the way around the page and come back to the modal. So that's super helpful. And then there's some styling utilities in there too. So like CDK visually hidden for elements only accessible to assistive technology. I will say that the CDK has a larger learning curve if you haven't worked with it before. I still recommend using it. It's great if you're going to work with Angular, but just know that there's a lot of documentation on it, and it's important to read up on it. And I think I'm good on that page. So the next tool, which I know some people are a little more interested in, is Storybook integration. It's very easy to import, very easy to implement. Basically, you just have a component and you have props. You can use add-ons. So the add-ons are going to be things like knobs, documentation, story shots. So if you're doing testing and you want to make sure that visually there was no changes from the last time that you modified the component, maybe your text is way too far left now compared to before, you can do that with story shots. Viewports, you can test on responsive viewports. So lots of add-ons, pretty awesome. I'll show you an example of it in a minute. For stories, you should put them in the same directory as the component that they're referencing. You don't have to when you have Storybook in your project initially when it inits. It'll allocate its own folder for it, and it's perfectly fine to keep it there, but it's more helpful to keep an eye on your stories where they're located in respect to the components. And the last small thing to know about it is that they use the fork TS checker webpack plugin, so TS config is required. So we pick our tools, and now we need to build the components. It's probably a terrible transition, sorry, but we're at this point, like we've kind of covered everything, we've exhausted what we need as far as building them. Now we just kind of need to do it. We've got our specs, let's go. So when do we add a component to our library? Very, very important. Components should not be added to a library if they are a one-off component. So if it is a image that you can drag and drop around the page, and that's all it does, just drag and drop functionality of an image, and you'll never use it again, it does not belong in a component library. If at some point that component gets requested by developers and by UX and by product, then we can go ahead and start talking about it and get a spec for it and start implementing it into our component library. But by adding a bunch of components that won't be used at all, like maybe nobody's ever requested a modal, so nobody will ever use the modal, nobody will want to use the image drag and dropper, we're cluttering our library, right? So our library is supposed to be easy for our devs to use and read and implement components from. We don't want to clutter it with components that are never going to be looked at by anybody. It's helpful for us. It's helpful for people who are going to use it in the future. A lot less work that doesn't need to be done. And the component needs to be spec'd out properly and signed properly. We're going to need to talk about architecture, behavior, look and feel for the brand. UX and UI needs to look at it, make sure it's accessible. It needs to be very, very deeply looked at and very deeply approved by everyone who will be using this component library. And component naming and patterns. So going back to kind of our little, not so much, but a little bit architecture of the components. It's really easy to generate a component to include its tests, its HTML, have all the prefixes auto-generated. You can use the CLI command. It's pretty nice. Prefixes are set within the angular.json. So if you're looking to change a prefix, it's a good place to start. You can just go in and, custom change your prefixes too. That's fine. That's cool. You'll probably want to do that anyway sometimes as the ecosystem evolves. Every other thing is more like a generic software development process. Like, do not repeat yourself. Components should not do the behaviors of other components. You shouldn't have a button that can be clicked on and project information, and then a second button that is a completely different component that you click on, it projects information, but maybe that information projects in green coloring. That's not a separate component. It's the same component, and you want to work with that. Decide on the syntax of the component selectors, kind of going back to prefixes. Use kebab case usually is the recommendation. Make naming concise but explanatory. So DLS radio button group versus DLS group of radio buttons. The second one typically is a little more frowned on. We can be concise by just saying the DLS radio button group. And for services, as far as naming is concerned, if it's an agent noun, meaning it's like log, so it's a logger, you would want to use ER. But if you want to do something like a base service, you would want to just append service at the end of base. So next, and the component data. We're almost done, I promise. Sorry, guys. So for component data, you want to make sure you handle error states and values for inputs for anything actionable. So for Angular Forms, is a great example. It has built-in validation, and it allows you to track the changes in state within the model. So if something changes, you can pick it up immediately. You'll be able to see it, I guess, for people who aren't too familiar with Angular Forms, if you have a control, which is mapped to an input, and you type something in the input, and we log out that control, like in the browser or something, we can see those changes in what we've just logged out. It's very useful and highly recommended for component libraries. Other dynamic values not related to that kind of behavior, we're going to look for observables or promises. In general, you don't want to pass anything static unless it's something like a role or a label. So you want to make sure you're expecting what's coming in to change. Another important thing, super important, anything that's coming in as an input, be prepared to handle it as a null value. Especially for things that are attributes like tab indexes and labels. A lot of devs don't always read all the documentation, and at some point it's going to end up with that it doesn't get passed in at all. And if your component doesn't handle it ahead of time, you're going to end up with some weird console errors, or the component may not even render right, depending on what's null. So make sure you're ready to handle that. And when you're in the process of making these components, make sure you are ready for an enormous amount of data. If you make a type ahead, be prepared for how you're going to handle things like hundreds of thousands of entries coming in. Because when you implement this in enterprise, it's usually not just the 5 or 10 things you use to demo it with or use to dev it with. It's going to be a lot more data. So let's see. Let's do the next slide, I guess. And yeah, so last one before implementation is our testing. It's unfortunately almost always the last thing anybody thinks about, but is incredibly important. Using test-driven development, behavior-driven development, regardless, do testing. Every component should have their own test, and parent components should have tests of themselves and their actions. You don't need to test your child components from within your parent components. So if I'm testing something for, like, it has a card with a button, I need to test the card and make sure the button is there or it can be clicked. I don't need to actually test whether or not it expands or doesn't expand, or all these little functionalities that the button may be able to do. That's not the job of the parent component. That's the button's job as far as testing is concerned. We should probably have visual regression and unit testing. Some of those things we can use for that are just, we can do Mocha and Karma, Cucumber and Protractor, Jasmine and Karma, I think, which is what's pre-filled with Angular when you make a new app. Or you could use Cypress. Usually I see that people use multiple, so Just in Cypress or Jasmine and Karma in Cypress. You kind of use them both. And component test harnesses are optional, but it's something that comes in with the CDK. It's pretty great. Makes the test a little bit less brittle. If you've ever written any tests, with Jest, usually you have to do things like query selectors, grab things by the CSS or with HTML. And this completely eliminates the need for that. You can go ahead and just test and wait on an action to complete. So it also removes the change detector ref dependency. And the tests are so much smaller after you're done. As you know, a 40-line test goes from 40 to maybe like 15. Something worth looking into if you're having some trouble with readability in Jest tests. So we're just about at the 40-minute mark. So I'm going to go ahead and show you this application that I've built. Give me 1 second to transition over. Let's see here. Do screen share, present, a window. I think it's this one. You guys should be able to see this now. Should be the component library. Hoping it is. Let me know if it's not. All right, so again, as I prefaced a little bit earlier, I went ahead and generated this library already. I didn't think we'd have time to make a whole new one. I kind of was right on that, so I'm a little bit glad I did. But this is what we're going to be looking at for a library. We've got Storybook integration up here, as you can tell by the .storybook. If you want to open that, it's got a main.js, it's got a preview.js. We'll go over all this in a minute. But importantly, inside the project that we've generated, we've got our source, we've got a lib, and we've got our components. Folder structure is really important. It varies from person to person as to what they want their folder structure to look like. But having your components isolated in their own section, because you may be using services, or you may have something else like helpers that you want that are separate from the components. You just want to make sure you have a good structure to find everything. So the one that I made was a button. It's very simple. I went ahead, let me see, there's nothing in these service and spec files, I'm sorry. So we won't need our ng on init, but usually if you're going to do anything behaviorally, ng on init's a great thing to implement. We have our selector up here. I called it custom library button. And the template URL is right here, the mybutton.component.html, and then the styles URL is the mybutton.component.scss. You can use multiple style URLs, it's your choice. And the only thing I have in here right now is this text is visible, and we have it set to true. We'll change that in our HTML. So if the text is visible, we'll want to show this text. You wouldn't do this in a normal component. This is more for demonstration purposes, but this button is not. So we have a regular HTML button. We gave it class myButton. We gave it the role of button, a tab index of 1, so it's keyboard navigatable. And on click, we show the text. So in our classes, we have the background color. I picked this from an accessible color palette. I can probably share that at the very end. There's some great resources out there to pick color palettes for you and tell you like what color combinations are accessible and which ones aren't. I chose to put a border around my button. Font weight is bold, and padding is in the 8-pixel baseline. The text, I had a little bit of margin inside, and I did a display flex for a button container. Your choice if you want to use flex or if you want to do like a grid-based system, totally up to you. So as far as Storybook is concerned, a couple of things here. I'm going to actually go ahead and serve that up so you guys can see. And I'm going to go ahead and share my screen again, but I'm not going to share the just the code. Let's do my entire screen. Yeah, let's go ahead and share that. Cool. So while this screen is open, this is the accessible color palette that I used. Down here, I can put this in the meetup page later, but it tells us, for example, like these colors are not compatible. They don't fit the contrast ratio. So you don't want to mix the black background with the black text. There's no contrast ratio whatsoever, and it's terrible. But you could do like the white backgrounds with the darker text. So just some things to look at. I chose to use medium and dark for the border and for the button background, and white for the text. So this is Storybook. Basically, I went ahead and initted Storybook. I believe it's npx sb init to do that, and it builds out all this like .storybook folder directory. And puts it in for you. You don't have to worry about it. It builds out a stories directory, and it includes these custom stories that I've deleted, and I've added my own. But everything comes in for you, and you can kind of just do whatever you need. So for the button story, I brought in my component. I added a decorator. This is one of those add-ons. It's the with knobs. And I have my props. So that display text from earlier from the component, which will be here, it's an input. So I can actually, within Storybook, go in and say, all right, for my input, it's a display text. I may want to change it and play around with it. So it's a text input, and my default is button. And then in my Storybook, when it renders, I can change the button text. Super simple. You can test things like how your button handles excessive input like this, how it looks. It's really nice. You can do other inputs like the background color. You can do things like actions. So you can tell what happens if you click it. Mine doesn't have anything as far as actions is concerned. But you can just play around with it in here, and it's super great for local development. So I think that's all we need for that. You don't have to put it in as a peer dependency. It can just be a dev dependency. I guess it's important to note. There is an option for docs. So one of the add-ons everybody likes to use is docs. You can customize your docs here in the preview.js. If you don't include that, it renders it like this. It has like these pre-built documentation pages for your components. Works the same as your regular canvas. If you have this, you can kind of see the code a little bit better, but if you want to customize them, you add in a parameter here called docs. If you do null, it's nothing. If you do like this, like you want to implement your own component here, it puts in a blank page. And if you're going to, so another way that you can normally do this is something like this, and then including some HTML in here. So I could do like that, and it's perfectly fine with that. Now this won't work for us. There's some issues with the loaders. You'd have to do some configurations with your loader to make this work. It's a little bit better with React, but you can make this work and pretty much use Markdown and make your own custom documentation page. But I'm going to go ahead and hold off on that for now. So it's really nice. There's, like I said, there's more add-ons that come with the Storybook. Definitely look into it if you're doing a component library for both your devs and yourself. And finally, I was just running, actually, it's not even in this terminal. We'll close Storybook out. So lastly, I just went ahead and packaged the library up. So I have my component, I have my Storybook that I can play around with while I'm deving it locally. And now what I want to do is put it into an actual application and know that it works, right? So in my application, my presentation app over here, I went ahead and in the app component, in the app module, yes, I imported this components module from my library. So if we go back to my library and we look at the my library, we close our components, we've got this public-api.ts, which exports our module. And when we go into our module, right here, our components.module, this declares and exports our button component. So have your module. For this, like in this structure, for example, you could put multiple components in this module, which would be the idea. So I could have like a button component, input component, a bunch of other components, and then export them with the public API. And then import them from, in our case, it's node modules because it's local. Again, if you publish to NPM, you can just use your package.json. So import the module, which will bring in our component. And then in the HTML, all I have to do is put in our selector, and it will, with the display text, our customized input. And then it renders our library, which is right here. And we click on it, and we get our text that I was talking about earlier. This one is accessible. I was told I should probably go ahead and let you guys hear the voice. I use Chromebox. It's a screen reader. So give me a second here if I can do my extensions, and I will do this out loud. Yep. Sorry, one second. I have a voice yelling in my ear. Let's go to sound.
No custom component library tab. Click me button. Yeah. Angular logo here. There be custom components. Click me. Congrats on your first component library.
This is a screen reader. It's wonderful. And if you tab it, so I'm just going to use the tab button instead of clicking around.
Congrats on your first component library.
And it
click me button.
I can use. So sorry. I'll refresh the screen.
Custom component library. Click me button main.
If I hit enter,
click me button.
The button pops open. And this is because we're utilizing things like tab index and assigning the role of button. So if you do want to make something accessible.
Custom component libraries.
Yeah, if you do want to make something accessible, this is the way to do it. So yeah, that's kind of my presentation, I think. Let me get my headphones back in so I can take any questions if you guys have it. And if anybody like feels qualified to answer the questions, please do so. Because I'm still a little bit nervous even after 50 minutes later. So if anybody has any questions, you guys can let me know. And I'll stop sharing screen now.
Hey, Maria, I'll just say we adopted Storybook for custom components 6 months ago. I'm not on the front end team, but I go to all the stand-ups and all the lunch and learns, and like all of the stuff you covered were the concerns we had, and everybody's a big fan of it. And we're now trying to extend it further left up into Sketch and Figma and other things. So yeah, we're a huge fan of it for anybody that hasn't tried Storybook yet.
So
yeah, I definitely recommend it.
Yeah, this looks really awesome. I think it'll solve some of our problems too. One thing, I'm not quite getting how it's framework agnostic, because it seems like what you implemented is pretty closely coupled to your Angular component.
Yeah, so are you talking about Storybook or about web components? Because we weren't building web components, we were just building components in an Angular library. So these are Angular components.
Okay.
If you want to make them like framework, framework compatible, you would use Angular elements,
Right.
which create those web components. But in our case, we didn't do that, just simply because A, for time, and B, I don't think most people need framework agnostic components. But that's something that you need to discuss as a team, like depending on what you're doing.
Right. We actually have a front-end microservices platform. It's all kind of, authentication, authorization, and, all the cross-cutting concerns are kind of bound together through Nginx. But we do have a framework that allows pretty much any modern SPA framework to be used. It's up to the team what they want to use.
Mm-hmm. Yeah,
so
I think in that case,
you need a cross-cutting, something like Storybook that is cross-cutting, like, okay, so I want to implement whatever, a button, what should it look like?
So Storybook is compatible with React and Angular, and I think they're also compatible with Vue. As far as, yeah, so I mean, it works with most of the popular frameworks. I guess I can't say for every single one of them. But if you're a front-end developer, usually you're using one of the three. So, you can also, honestly, you can build your own sandbox too. If Storybook isn't actually fitting all your needs, it's completely possible to build your own sandbox. It just takes a lot more extra effort. So whatever works, just whatever works for you. You definitely don't have to use it. It's just great if you're using something like just Angular components or just React or Angular and React. Having something pre-built like that is really nice.
Gotcha.
Cool. Any other questions?
Hi, go ahead. Okay, yeah, I added a question earlier. Was just curious about Confluence and adding a code sandbox to it. Did you create a custom component that would evaluate the code, or is there some sort of plugin?
For Storybook?
Yeah, for nesting it inside of Confluence.
Oh, for Confluence. Honestly, I don't remember. Part of my job when I went there was to not do that anymore and create our own custom sandbox. That's what I was actually doing. So I'm not sure how they did that. I don't even know if you can do that anymore. Probably somebody on the UX on a UX team would have a better idea of that because it's more of like an older UX practice than anything.
Okay, cool. Thanks.
Mhm.
Is it Maria? Is that correct?
Maria, I answered it both,
Mariah.
honestly.
No, I like to get it right. So Mariah, what did you use for testing? You covered a lot of options, but what do you personally use? I'm just interested in that.
Yeah, I personally, in every team I've been on, we've used Jest and Cypress.
Okay.
Cypress for visual regression testing, and for like unit testing, we use Jest.
Okay.
It's just, as far as I know, like Jest is built off of Jasmine. So, I mean, using Jasmine and Karma isn't a bad alternative. It's just that Jest has everything kind of built in one with the runner. So I find it a little bit easier to use.
Fantastic. Thank you.
Mhm.
I have a
Cool.
job posting to announce if we go to
Yeah.
open session.
Yeah, for sure. Like,
yeah.
at this point, like, if anybody has any other questions, feel free to ping me. And yeah, go ahead. You can job posting.
Yeah, that was a great presentation. Thanks.
Thank you.
Hey, I'm the co-founder for a company called Real Theory. We're not far from launching. We're 25 engineers.